Hello everyone. Am I properly audible to you people? Good evening. Hello. Let's wait for 5-6 minutes so that other people can also join. Okay, Manthan, thank you. Hello, good evening, Neha. If you people have any doubts related to the previous classes, you can ask now. Good evening, Reshma. If you guys have any doubts, you can ask now. And I believe that all of you must have attended the previous classes, from which the starting two were based on basics of Python, and the third one was based on the libraries that we use for data preprocessing. Am I properly audible? If you guys have no doubts, so let me ask you some questions. We studied list, tuple, and dictionary. So, and we divided list and tuple into one part and dictionary into one part. And we discussed, so what's the difference between dictionary and list and tuple? What kind of sequence they are? Good evening, Sona. So tell me the difference between dictionary and tuple and list. What kind of sequences they are? We discussed this in the second class only, and I believe the PPTs have been shared with you. So you can guess also. You can make any guess. You don't have to be correct. At least try. So no guesses, not even one. If you don't know the answer, write no in the chat. Good evening, Vaishnavi. If you guys don't know the answer, write no in the chat. Then I'll explain you once again. Yes, exactly. List and tuple are ordered collection of data. They're ordered sequence and dictionary is unordered sequence. HF zone, we can also use list and tuple also in that case. But most of the time we avoid tuple for huge amount of data. Yes, Praveen, list is mutable and tuple is immutable. So as you answered that list and tuple are ordered collection and dictionary is unordered collection. So why we are using these terms? How can we know that what is ordered collection and what is unordered collection? Answer me this, then we can start with the class. How do we know that list and tuple are ordered collection and dictionary is not? Any guesses? If you don't know, you can write no in the chat. I have absolutely no problem in explaining again. You can write no in the chat. Ordered collection are unchangeable. But someone already mentioned in the chat that list is mutable and tuple is not mutable. That means we can change the items present in the list. And list is also an ordered collection of data. Good evening, Vikas. Okay, so let me tell you what is ordered collection and what is unordered collection. So is my screen properly visible to you guys, or do I need to zoom in? Yes, Texting, ordered can be accessed using indexes. Yes, you are right. So let us also see an example for other people. Like if I'm declaring a list using variable LT, suppose, then I need to use square brackets for the list. I'm having this, a list 1, 2, 3. And if I'm declaring a tuple, let it be TP is equals to, I need to use round brackets 1, 2, 3. Now I want to exists any single element in list and tuple, then I can simply write print lt, and at which index, suppose I want 2, then we can see it is at index 1. So I can write lt index 1, and for tuple I can write tp index 1. So we will get the numbers at index 1 of both tuple and list. Let me run it again. It's not running. Let me refresh the page once again. Let me reload it. I believe this site is not working today. So let me use Google Colab only. Let us create a new notebook. Like I told you in the first class, Google Colab. Let me create a new notebook. So here we are. Let me paste the, let me type the code here, lt list 1 2 3, and if I want the first index, lt 1. Let me run it. So yeah, I'm getting 2, and for tuple also same. If I want the first index, I can write this 2. But in case of dictionary, we don't use this indexing. We need to mention the key. Suppose 1 is the key, then I have 4 as the value, then 2 as the key, and 3 as the value. If I want something at first index, let me change the indexing. So let me write it 10 here. So yeah, if I want something at first index, I'll run it. It is giving me an error. So for dictionary, we need to use key values. So if I'll write 10 here, it will give me 4. But if I'll write 2 here, it will give me 3. Is it fine? I believe now you know what is ordered sequence and what is unordered sequence. Okay. So let's move to today's topic. So today we are going to discuss about the introduction to machine learning and one of the algorithms in detail that we will be using on the real data also. And then using this algorithm only that I'll be explaining you in some time, we will be making a stock market prediction model in upcoming classes. So is my screen properly visible? Should I zoom in? Good evening, Yogesh. Shall we start? Okay. So what is basically machine learning? Any guesses, like in any one line or something? Can you guess what is machine learning and why do we need it? Any simple guesses in normal language? Why we want to use machine learning? What is the concept that leads us to machine learning? Any guesses what is machine learning? Yes, Vikas. Yes, to predict something, we need machine learning to predict something. Any other guess? So let us start. You can consider the most basic thing that we humans always learn from our past experiences. Okay, like we always learn every time we make some errors in code also. Yes, Prakriti, to reduce load of human, and we want work in proper way. To reduce load of human is more accurate. Very good. Like I was saying that for humans, we always learn from the past errors. If we are writing some code, then also we make errors, we learn, then we write proper code. That is also a kind of experience only. But for machines, machines always follow the instructions that we are giving to it. So that you must be aware that each line of code is an instruction that we are giving to the machine. Yes, Mahir, you are correct. Yes, Prakriti, train a machine to done work accurately. So each line of code that we are writing is an instruction that I'm declaring list like this. This is also an instruction. I want the first index of the list. This is also an instruction that I'm passing on to the machine, and it is giving me the answer. So we humans learn from experiences and machine follow what we pass on to it in the form of instructions. If we combine these two things, that means humans are training machines to get their work done. So this is where the concept of machine learning starts. Is it clear? So what is machine learning? You can go through the very basic definitions, like many of you also wrote in the chat box, that to reduce the load of human we need machine learning. So by using machine learning only, we have different applications in machine learning, like image and speech recognition, medical diagnosis, and so on, classification, prediction, extraction, regression, one of the important one. So these are the applications of machine learning. Is it clear? I believe it's clear to you guys. Okay, so next. So how to develop a machine learning model? For developing any machine learning model, we need a data set. Like in the last class, we worked on a data set of food, about the varieties of food, different categories of food. We worked on that. So we need a data set. Most of the time we need it in the form of CSV. You can have other files too. Okay, Vaishnavi. Okay, Mahir. So we need a data set for machine learning. So this is the first step. Now pre-processing of data. Like yesterday we were slicing the data into different parts. I was just accessing a single column from the whole data frame. So all these things come under the pre-processing part that we learned yesterday. Next, we have different kinds of library. Again, we have like we learned pandas, matplotlib, and numpy, all this. We also have sklearn, using which we can import different kinds of data pre-processing functions, and also we can import some models of machine learning, to which we just need to pass the data that we will be learning after some time. So next, for machine learning, if we are feeding the data to the machine, so we need two parts of the data. Like first is training part, next is testing part. Why do we need testing part? Because if we are training the model, we also need to check if it is giving the correct answers or not. So for that, we need training and testing both the data set. Also, we can divide a single data set into two parts that we will be learning today only, how to divide. Next, so now we come to types of machine learning. We basically have three types of machine learning algorithms that we can have. So, supervised, unsupervised, and reinforcement learning. Today, we will be covering supervised learning and unsupervised learning. And for supervised, we will also be implementing a code in detail for one of the algorithms we have in supervised learning. Should I start with supervised learning, or you guys have any doubts? You can ask now. If you guys have any doubts related to machine learning, like till here, you can ask. Should I proceed with supervised learning? Okay, Vaishnavi, no doubt. So next, what is supervised learning? So for supervised learning, we provide data to the machine, but in the labeled form. This is the main thing that separates supervised learning from the other two ones, that is unsupervised and reinforcement. So is this image properly visible, or should I zoom in? Let me zoom in. So in this image, you can see this is my machine. I'm passing on some data to it, but the main point is I'm passing the labeled data. I'm mentioning that this shape is of rectangle, this is of circle, this is of triangle, and this is hexagon. I'm telling my machine. Then I also have some separate test data that I'm using for getting the values. So it is giving me the prediction that this is triangle and this is circle. So this is supervised learning. Like I'm giving the data to the machine, but I'm also passing on the labels. Like features plus labels, I'm passing both the things in supervised learning. This kind of shape is a feature, and a rectangle, circle, triangle, hexagon, it is machine. What do you require ML? Mobin, can you repeat your question? It's not clear to me. Why do we require machine learning? Is it what you are asking? Pratyush, if we will have time at last, we will surely deploy it. I cannot guarantee this, but yes, I'll help you in making the whole model. Don't worry about that. So, Mobin, what you were asking, like, why do we require a machine learning? As we discussed that we need machine learning because uh, we want to reduce the load of human. For example, we are humans pass the instruction to the machine, they train the machine to get their work done. You can get different predictions. These are the applications of machine learning. Like you can get different predictions done, you can extract some data, you can also do image recognition and speech recognition too. Like you must be using Google, so or you must be having Alexa. So in that also machine learning is AI and ML is used. That is it is recognizing the speech that you're telling, then giving you the answers. So now I told you about supervised learning. So here we pass features plus labels of the data to the machine. Is it clear till here? If you have any doubt, you can ask. For now, supervised machine learning, we have two types of algorithms. One is regression and one is classification. Under that also, we have different kinds of algorithm. Like under regression, you can have linear regression and logistic regression. Similarly, with the classification too. So in regression, you have, of course, two types of variables that you need, input variable and output variable. You need to find a relationship between those two. So this is used for predicting the market trends or weather forecasting. And for classification, we'll be have two types of output only. Either we can have yes or no or true or false. Anything that we have only two values, we can use this classification method. But for regression, we can have more than one type of output. What are the advantages of supervised learning, Vikas? So for that, you can see we'll be implementing a stock market prediction model using linear regression, which is a type of supervised machine learning algorithm. You can predict the values. So this is one of them. Is it fine till here? You can work on real life data for supervised as well as unsupervised also. But most of the time supervised is more accurate because we are telling the machine that these are the features and these are the labels of the data. So this is an example of linear regression and this is an example of regression trees. We'll be implementing this one in just a while. So for linear regression, we have two types of variables. One is independent variable, which does not depend on any other factor of the data, and one is dependent variable that we want to predict, which will be depending on the independent values. This dependent variable will be depending on other variables. So this is how you work in linear regression. And for regression trees, as I said, that you must have only two answers, yes or no. So you have only two types of output variables here in regression, in classification, or we can say regression trees. Next, again, classification, we as I said that you have many more algorithms like logistic regression, decision trees, and random forest. We'll be discussing logistic regression in detail in the next class. For this, you can remember that logistic regression always have a S-type curve, like you can see here. It is known as sigmoid curve, sigmoid graph, because it is S-shaped. Is it okay till here? If you guys have any doubts, you can ask now. If you people have any doubts, you can ask now. Should I move to unsupervised learning? If the theoretical part is clear, okay, Vaishnavi. So next, unsupervised learning. So as you saw that in supervised learning, we were passing features as well as labels to the machine. But in unsupervised learning, I'm just passing the features. That is the shape here. But I'm not passing that this is circle, this is rectangle, this is triangle. This is what machine is separating them on their own on the basis of features. This is one of the part that I said that most of the time supervised is more accurate, but unsupervised can also be accurate depending on the data and depending on the code you type. But here you can see that we are not passing on the labels to the machine, and machine is segregating these shapes on its own without knowing that this is circle, this is rectangle or hexagon. Is it clear? Is it clear till here? Next, in unsupervised also we have clustering and association. In clustering, we have different clusters formed in the graph. Like we'll be having two separate clusters, and if we want have any third kind of value, then we can compare that how many yes are there, how many no's are there, and then we can have the answer for the clustering. We have two different kind of categories in clustering. Okay, Neha. Okay, Preeti. Is it clear? In clustering, we are dividing a particular data points into different number of groups. We are grouping them. And for association, we need to find relationship between different variables. In the when we have very large data set. Is it clear till here? Should we move on to the implementation part? We have different kinds of implementation for all of the algorithms, but we'll not be covering this, but we'll be covering for the linear algorithm, linear regression part. Is it clear? Shall we move to the next part? Do you people have any doubts? Okay, so for the linear regression, today we'll be implementing this linear regression. So what is linear regression? It is one of the algorithms of supervised machine learning, under which we have two types of variables basically. One is dependent variable and another one is independent variable. So in linear regression, we have two types of variables, as I said, that one is independent and another one is dependent. So we follow the equation here, y is equals to mx plus c. You can see here m is the slope and c is the constant. And y is the dependent value that we need to find. that we need to predict, and x are the for x we pass on the independent variable. Most of the time we pass it in the it in the form of data frame, or basically arrays, because we can have more than one independent variables too. But for y, we will always be having only one independent variable that we need to predict. Okay, Vikas. Okay, Neha. So next, let us simply go to the implementation part. Then we will discuss another example given in this PPT. So again, as I told you, for working on any CSV file, you first need to upload it using this. So I've already uploaded the price CSV that we will be using. So again, before starting, we need to import the libraries for pre-processing. So if I'll run it, then now I have imported NumPy, Matplotlib for graphs, and pandas also for data pre-processing. So here I'm reading my CSV file using pandas library. I need to pass the name of the CSV file properly. Then now I'm dividing my data into two parts. As I told you that we need two parts, independent variables and dependent variables. So let me print also data for you. So this is the CSV that we have. See. So this is the CSV that we have. We have area in square feet and price in dollars. So it's obvious that price will be depending on area. So that's why we have taken area as independent part and price as dependent part. Area as independent and price as dependent. Is it clear till here? We have divided the data set into two parts, and for dependent one we have 1D data, but for independent one I told you we need 2D data, that is data frame, or then we'll be converting the values into array also sometimes. Is it clear till here? Should we move to the next part if you are clear with independent and dependent variables? How to categorize different variables into dependent and independent, that you will get to know after seeing the CSV only. Like after seeing this file, you can get that price will always depend on area, but area is independent of price. Now, is it clear? Okay. So next thing, how to check the data type and NaN values. Like for data pre-processing, if we are passing a CSV file basically, if we are having any null values, then it will be a problem for us while predicting. So I'm just checking that in independent variables, if we have any kind of null values, or what is the info of that independent variable. So I'll run it and I'll get to know that there is no null value here. Oh, okay. So the messages sent to me are displaying late in the live chat. I believe that maybe some connection problem. I'll try to rectify it after the class ends. So now we want to split our data. As I told you, we need two parts. One is training part and one is for testing part. So we'll be doing that using sklearn library. So I'll be importing train test split function using sklearn.model selection. So I will be passing my independent variables, then dependent variables, then test size and random state. For test size, you can pass any test size, like I have passed 0.1, you can pass 0.2 also. And for random state, I believe that you can also pass any other number. So let me run it here. I'll be getting four types of I'll be getting my data divided into four types. One is X train, X test, Y train, and Y test. Here Y is for dependent values, see dependent, and X is for independent values. We are having two types, like we'll be training the machine with X train and Y train, but we'll be testing the machine based on X test and Y test, and Y test we'll be using for comparing the predictions that we are having. Is it clear till here? Should we move to the next part? Okay, Neha. So next, for now, we also need to import linear regression, the algorithm that we are going to use. So for linear regression, again you need sklearn library. So from sklearn.linear model, you will be importing linear regression. So what is this LNR? Here I am making an object of linear regression. Like I don't need to type linear regression full again and again. So I'll be using LNR instead of the whole word linear regression. So this is the function. This dot fit is always used when we are training our model. So for linear regression dot fit, I am passing my values, that X train and Y train. First we are passing the independent variables, then the dependent part. This is function only. Let me write it completely. Yeah. So this is function for training the model, or we can say machine. Now, as I told you that we follow here y is equals to mx plus c here, where c is the constant or intercept. In like in maths also you must have done this. And slope, m is the slope. So how to find out these two values? Using lnr dot coefficient, that is coef underscore, and for finding out intercept you need lnr dot intercept underscore. Then I am getting both the values printed. This is the slope and this is the intercept. Is it clear till here? Should we move to the predicting part? If you have any doubt till here, you can ask me. I'll repeat it. Is everything clear? If you have any doubt, you can ask. I'll repeat that code snippet again. Okay, understood. So I believe no one is having any doubt. So next, okay, Vaishnavi. So next, now let us see the value of X test that we will be using. Let me comment out this part. So this is the X test that we have passed. These are the indexes values, but this is main that for this area, how much price should be there. So next, so we need to predict it. So we are using X test for this. Okay, Vikas. Okay, HS zoom. So yeah, so now for predicting y, you can use any variable here. So I've used predicted y. So I'm using the function lnr dot predict function, and I'm passing the x test for it, for getting the price values. So now to check what I'm getting as the predicted values, you can see these are the predicted values that I'm getting in the form of a list. Is it clear? It is predicting the value. A model is predicting the value. Is it clear? Is it clear till here? Okay. So now we are getting these values. Now we can also check that what were the real y tests that we had and compare both the things. You can get it printed afterwards. Okay, Avinash, I'll be sending you the attendance link at 7:50. So now we need to calculate the errors of a model so that we can do using sklearn.matrices, and you can import mean absolute error and mean squared error, and you can also import square root sqrt from math library to calculate root mean squared error. So for that you can simply pass on the x test value and predicted value that we got from here to check the errors. So this is coming very large. The reason, basically the main reason here is because we have very less data. The most important thing in machine learning is, let me write the text in the form of text here. The most important thing in machine learning is more the data implies that we can have a better model, which implies that we can have good accuracy. We will be having predictions from this model too, but we only have, you can see, only 39. That means starting from 0. So we have 40 columns on for 40 rows only. So this is very less. At least we need more than 500 rows to get the more accuracy. So that's why we are getting too much of error. Now to how to reduce this error, you can use you can pre-process your data set again using sklearn only, sklearn.preprocessing. You need to import polynomial features. Here you will be transforming your data. Then you can get your predictions done again. Then you can again check this error, which will be only improved if we have large data set. Then we get back to the same thing, that we need more data, means better model, means good accuracy. For the project that we will be building, we'll be having so much of data. Like yesterday also we worked on food.csv. There we had more than, I believe, 7,000 plus rows. We had 7,000 plus rows. So that's why we were getting more good, we will get more good answers in that case. But here we just have 40 rows. That means only 40 values for area as well as price. So now we have predicted, we have trained the model. Let's see, get printed the x test and y test. So here the green color is for the x test and y predicted y's value, and here red color is for the x test and y test comparison. Is it clear till here? Like we can see the values that we are getting are somewhat close to the values that we already had in the CSV file. Now again the equation that we have, y is equals to mx plus c. We'll discuss it. If you have any doubts still here, you can ask now. Okay, in the meanwhile, I'll share the attendance link with you people. I've shared the attendance link with you guys. You can mark your attendance for the 4th day. No problem. You can attend this class, or you can see the video afterwards after this uh, live session ends. And in the description of the video, you can find the attendance link also. Today we just covered some ML algorithms, and we just implemented one algorithm out of those, that is linear regression. Okay, Vikas, no doubts. So next, as we discussed, that we have this equation in the case of linear regression, how to calculate coefficient, how to calculate slope. We have that is coefficient and slope are both are same thing, and how to calculate the intercept or the constant are same thing. This is similar till here. Here, for getting the value of y predicted, we need to pass the value of x. So this is how it works. You can match like this value. If I'll run it, you can see here in predicting part also I'm passing 1900, and here also I'm passing 1900. So you can see the answer that I'm getting as the price of land is similar to the answer that a model is predicting. You can compare these two. So this is how linear regression follows y is equals to mx plus c. You can compare these two things. And for the last part, you can pass any value from your end in this function in the form of data frame. That's why I've used the square brackets 2 times here. So for 1980, like 1980, we are getting this value. So let us compare to the CSV that we have. Let me open the CSV file too here. So yeah, you can see for 1980, it is around 93,000. The model is also giving us the answer of 90,000, but like it is not accurate because of the data, but it is around 93,000 only. It is giving us answer close to the value which is accurate. So this was all about linear regression. If you have any doubt, you can ask now, or here you can change the value also. Let me see for 1600 what we get. We are getting 77,000 something. Here we are getting more. Its price is something 71,000 something. So it is close to the value, but not accurate, but close to the value. But if you will pass on more data, then it will give you more accurate value. You can compare these results. It is giving us answers near to this. This shows that we are not explicitly passing the data to the machine. Basically, we are training it. It is giving us answers around the values that we have given. Is it clear? So this is how you implement a linear regression model. Is everything clear? Is everything clear? If you people have any doubts, you can ask now. Let me share the attendance link again. So if you people have any doubts, you can ask. This was all from my side for today. And in next class, we'll be discussing the third method of machine learning. Okay, Mahir. Okay, Chip Zone. So I believe you people have no doubts, and in next class we'll be discussing the reinforcement learning, and we'll also be implementing the second algorithm of supervised learning only, which is logistic regression, which gives us a sigmoid curve that we discussed, S-shaped curve. What is the basic equation that it follows? And in next class you can come prepared with any doubts. If you have any doubts, we can also take separate 5 to 10 minutes for the doubts if you have any. And after day after tomorrow we'll start implementing our project. So thank you everyone, this was all from my side. Thank you for being so patient and listening. Bye bye. Thank you.